quantities together to achieve a homogeneous mixture. In front of me, I have a really small quantity of red dye and a much larger quantity of white powder, which in our case is lactose. We'll now use geometric dilution to combine these two powders in order to obtain a homogeneous mixture. We'll start by adding the ingredient of the smallest quantity into our mortar. Next, we add an approximately equal amount of the powder with the larger quantity into the mortar. This quantity does not need to be exact and can be eyeballed. Once we have approximately equal quantities of both powders, we're going to go ahead and triturate the powders. While triturating, we're mixing our powders very well, but also trying to reduce particle size to get a fine, homogeneous powder. After each mix, we're going to scrape down our pestle and the sides of our mortar and collect the powder in the center of our mortar. Then, we repeat the process by continuing to add an approximately equal quantity of the larger powder into our mortar, followed by mixing until all the powder has been added. This larger powder is considered our diluent powder, and this is where the term geometric dilution comes from. After each approximately equal addition, you are diluting to the starting ingredient of the smallest quantity. When we have an equal quantity of lactose powder added to the mortar, we're going to triturate again. Make sure you have a nice, firm grasp on the pestle to get full contact of the pestle along the sides and bottom of your mortar to really grind down the particle size of the powders. Once again, after we're done mixing, we scrape down the mortar and pestle. You'll see with each addition of the larger quantity of powder, we have a fainter and fainter color. We use that red dye as the ingredient of the smallest quantity, so we can visually inspect the powder blend and the geometric dilution process occurring. Now that we have approximately equal quantities, let's take our pestle and triturate. Instinctively, it may seem okay to just dump all the powders together in the mortar and mix. With this process, it is very difficult to effectively mix all the powders and get them distributed evenly throughout the blend. With geometric dilution, since we are doubling each mixing process, you are able to achieve a homogeneous mixture. Even though geometric dilution does take more time, it is definitely better practice. Once again, scrape down your pestle and sides of the mortar. As you see, we're really getting a nice, fainter pink color throughout the mix. Let's eyeball an approximately equal quantity of lactose and triturate. Always remember to be very careful not to use any metal spatulas in your glass mortars. These can etch the sides of your mortar, and we want to avoid this as powders can get stuck in these scratches. That's why these soft rubber or silicone spatulas are really nice to scrape down the sides of our mortars. You can get full contact with your mortar without scratching or damaging your glassware. Now, we're at the last addition as we're going to add all of our remaining lactose to the mortar. With these larger whey boats, it works well to hold them by the corners and pinch them together to fold them in half and tap the sides. To help get all the powder out of our whey boats, you can also go ahead and just flick the back to expel any remaining powder from the whey boat. Once again, go ahead and triturate. After we've mixed, let's scrape down the pestle and mortar and mix one last time to ensure all our powders are thoroughly mixed. Even though we did this geometric dilution technique using powders, this can also be used with creams, gels, ointments, and liquids. We now have this thoroughly mixed, and since we used red dye as the ingredient of the smallest quantity, we can visually inspect the homogeneity of the mixture. As you can see, our resulting powder is a fine